I will show the process of linear programming and how to solve an equation with different pieces of technology. Let's say the problem posed is a contractor builds two types of homes. The first type requires one lot, $12,000 capital, and 150 labor days to build, and is sold for a profit of $2,400. The second type of home requires one lot, $32,000 capital, and 200 labor days to build, and is sold for a profit of $3,400. The contractor owns 150 lots and has available for the job $2,880,000 and 24,000 labor days. How many homes of each type should she build to realize the greatest profit? Well, the first thing I do is organize the information. I tend to use a table, and tables can be organized both vertically and horizontally. I have two types of homes, so my second row says type 1 and my third row says type 2. My last bottom row is available. That's what the contractor has available. Vertically, my second column says lot, and each type 1 home requires one lot to build a house on, and there are 150 lots totally available. Capital. I wrote down how much it would cost for each house to be built and the amount of money available by the contractor to build these homes. Labor days were then put in, and I created a column at the end for profit. I know the profit for each type of home, but I don't know the total profit overall because the question asks, how many homes of each type should she build to realize the greatest profit? The next thing I did was I let X equal the number of type 1 homes and Y equal the number of type 2 homes. So type 1 is X and type 2 is Y. Then I wrote my objective function and my system of linear inequalities. The objective function is written now but not utilized until the very end to determine your final answer. In this case, we are wanting to know the greatest profit. So I use the profit for each home and write an expression or a function. Next, I write a system of linear inequalities, and that's done with the constraints. So I know there's a total of $2,880,000 of capital. Each type 1 home will cost $12,000 to build, so it's 12,000x, and each type 2 home costs $32,000 to build, so that's 32,000y. And I know I have to be less than or equal to the $2,880,000. For labor days, I know that it will cost or require 150 labor days for type 1, 200 labor days for type 2, and I have a total of 24,000 labor days of work. The third inequality has to do with the lots. X plus Y must be less than or equal to 150. Honestly, I could have written that first. I just chose to write it as my third one. My fourth inequality and fifth inequality have the constraints that I must have positive values, so I can't build a negative number of homes. Once I've written my objective function and my system of linear inequalities, I graph the system of linear inequalities to find the feasible region. So as you know, I've used the Desmos calculator before, and I would type in the different inequalities. In a bit, I'll have to zoom out so I can see the feasible region. Okay, I'm going to choose to not put on the inequalities 4 and 5 and just know that I have to be in quadrant 1. Let's see, I want to zoom out. That's what I want to do. So I get my feasible region on the technology here is where all three overlap. Sometimes it's a little hard to see pieces, so I'm going to zoom back in a little bit. Feasible region happens to have an origin here of 0, 0, a value of 150 on the right. There's a place where the lines intersect, and looks like it's 120.30. There's another point in here. It might be hard to see, so I can zoom in a bit. On the top, on the y-axis, that ordered pair is 0, 120. So if you're having difficulty determining where lines intersect, you can always zoom in on them. And somehow something seems off. Just going to make sure that my 288 is correct. Yep. Oh, I forgot to put the Y on my 32,000. There we go. Okay, that's better. So now using Desmos and finding that point of intersection, I have a 80, 60, and I also have 120, 30. Great. I chose to also do this by hand so you can see some of the next processes a little bit better. So I took that feasible region, and you'll notice that I chose to do the feasible region in white. Now we had the origin of 0, 0. That's a vertice of the feasible region. We have this point that is at 150, 0. There's a point at 80, 60, which is this point right here. This is 80, 60. There's a point at 0, 90. It's on the y-axis. And there's the point at 120, 30. If you're ever wondering if you have found the right point by looking at the graph, you are able to use other technology that we've done before, and that is with matrixcalc.org. So at matrixcalc.org, you'll remember that we had solving systems of linear inequality or equations, and I could type in, let's say I want to know where the red line and the blue line intersect. So the red line is 12,000x plus 32,000y is equal to the 288,000. And the blue line happens to be the 150x plus 200y equals 24,000. So I could ask that to solve with the Gauss-Jordan elimination, and notice that it says the ordered pair is 80, 60 for where the two lines intersect, and we can verify that on the Desmos graphing calculator that they do in fact intersect at 80, 60. So that's a nice feature. If I wanted to do that one more time and I wanted to know where the blue and the green line intersected, I could say that I had already typed in the blue equation that's on the bottom, and I need to type in the green one. So x plus y, and x is just 1 then, and y is 1, and it equals 150. I could ask it to find the Gauss-Jordan elimination method, and I see that it intersects at 120, 30. And we can verify that in the graph also. Okay. So coming back to the process of looking at all our vertices, once we have found all the vertices of our feasible region, and in this case there were 5, I need to take my objective function and determine which ordered pair, when substituted into the objective function, gives the maximum value. When I put in the ordered pair 0, 0, I got 0 for profit, which makes sense. When I build no homes, I get no profit. The ordered pair 150, 0 means I'm building 150 type 1 homes and 0 type 2 homes. That profit ends up being 360,000. If I build 80 type 1 homes and 60 type 2 homes, I end up with a profit of 396,000. If I have 0 type 1 homes and 90 type 2 homes, the profit is 3,400 multiplied with 90, and that ends up being 306,000. Then if I have 120 type 1 homes and 30 type 2 homes, I have a profit of 390,000. So I'm looking to maximize my profit, and that would occur with a $390,000 profit. So $390,000 is my profit, and I would look back at the ordered pair and see that that was 80 type 1 homes and 60 type 2 homes, which is interesting because that's a total of 140 homes. You'll remember earlier that we had available 150 lots. So looking back at our Word document here, we start with the process of reading the problem, organizing the information, write the objective function and system of linear inequalities, graph the system of linear inequalities to find the feasible region, and I would recommend graphing it with technology. Then you can use matrices or the Desmos to find the vertices of your feasible region, which we had found that there were 9 points for the feasible region. And after you have used your matrices to find the vertices, you need to then maximize or minimize the objective function. And in this case, the objective function was the 2400x plus 3400y, and it's maximized with 80 type 1 homes and 60 type 2 homes for a profit of $396,000.